Here we go. So, probability question. Permutations and combinations. We're dealing with the... I can't do it. We're dealing with the word divided. And the question is, how many different arrangements of the letters are possible? So, so what do we need to do? We know how to do arrangements. This is going to be... How many letters are there? 7. But we're going to have to divide by something because there's some repeated letters. So what are we dividing by? 3 factorial. 2 factorial. Which gives us... What does it give us? 420. Great. Which presumably is 7 times 5 times 4 times 3. Is that right? Once the 3 factorials cancelled. Part 2. In how many of these arrangements are all 3 Ds together? Well, that means we're now thinking about one item that is the 3 Ds. Now, of course, once we've grouped the 3 Ds together, they're just a group of 3 Ds. We don't need to think about anything more about them. It's indistinguishable what these 3 Ds are doing. So let's pretend that instead of 3 Ds, we've just got the letter D in green. We've then also got I, V, I, and E, which says divvy. So we're left with just strangely appropriate. We've just got five letters, of which 2 I's are the same. So our answer is 5 factorial over 2 factorial, or 5 times 4 times 3 is 60. Yes, 60. That's our answer for that. Remember, it makes no difference that these 3 Ds, we don't need to think about the number of arrangements, because we're not, if we were subtracting some arrangements from our original 420, then we may need to think about the 3 Ds as being different kind of patterns. But we don't need to think about that at all. It's of no relevance. We're saying that the 3 letter Ds are together, and that's it. They just count as one unit. Okay. We're dividing by the 2 factorial because the 2 I's that we have are not one unit. They can be interchanged and would look different when that happened. Ben's not entirely happy with that, but it's all right. The 7 cards are now shuffled and 2 cards are selected at random without replacement. Find the probability. Remember, we need to kind of remember when it says without replacement and stuff. Find the probability that at least one of these 2 cards has D printed on it. Whenever you see a question in which a small number of things are happening, like 2 things are happening, and it's saying at least one, it's often easier to think about the complement of that problem. So it's probably easier in this case to think, instead of thinking about what happens if at least one of these has D printed on it, what about considering if none of them have D printed on it? That's the opposite of at least one. So that's what I'm going to find out. Oops. So I'm going to do, for part 3, the probability that no letter D comes up. And that would be, well, not a D from the first card would be, what is that, 4 out of 7. And then we need to also have not a D on the second card, of which we now have 6 cards left. 3 of them are now the letter D, which gives us 2/7 as our answer. And we wanted that not to happen. So therefore, the probability at least one D is 1 minus 2/7. So probability of 5/7. You could have worked that out the other way by going straight for at least one D. Finding the probability of 2 Ds, finding the probability of D and then something else, or something else and then D, and adding those options together. You could have done a tree diagram. Any of these things would have been great. Okay? Good. Let's move on to the next one. Express each of the following as a single logarithm. Log base A of 2 plus log base A of 3, or part 1. Oh, we go. This is easy, isn't it? Just remembering the laws of logarithms, which are written on your poster. What do we get? Log base 96, yeah. Okay. Part 2. 2 log base 10 of x minus 3 log base 10 of y. What do we need to do first? We've got 2 of our log laws in action here, haven't we? We've got the n log base a of x, which becomes log base a of x to the n, or we've got the subtracting one. But it matters what order we do these things. So what we're going to do first? Turn them into powers. We're going to do the powers one first. So that's going to be log base 10 of x squared minus log base 10 of y cubed. Now we're subtracting, so when we subtract we divide the things in there. Log base 10 of x squared over y cubed, and that seems like quite a generous 3 marks, but there it is. Okay? Good. Any questions? Right. So that's the end of this royally grand video, and that's maths.